If you are visiting our channel for the first time, please subscribe first to get the basic and advanced maths concepts.
Hello everyone. Today we will learn that how you can find the domain of the trigonometric functions easily by understanding its concept. So before starting this, let's have a short concept of domain. Domain basically is the input to a certain function. So if the input is variable x, then it will be the value of x. If it's the variable y, then it will be the value of y, but it refers to the input to the function. It is not only the input, it refers to the valid input to a function, that refers to the valid out. So in this case we have the function sine theta, and in sine theta we are dependent on the value of theta, because theta is the input to this function that will give you with the value of sine theta. That will be the output. So we have to focus on the value of theta in order to find the value of the domain of the trigonometric function, as theta is the input, and we have to find the valid value of theta that will give you with the valid output. So how you can find it? We will start with the table. Here is a table of trigonometric functions at different values of theta from 0 degree to 360 degree. So if we see at the row of sine theta, we can see that sine 0 degree is 0, sine 30 is 1 by 2, sine 45 is 1 over under root 2, and so on. Now it is clear from here that sine is defined at all values of theta from 0 to 360. So as the case for any value of theta, that we are not getting any undefined value here. So we deduce from here that sine theta is defined at all values of theta, but theta should be a real number. So the domain of the sine theta will be for all theta belongs to real number. It means sine theta is defined at all values of theta, but keep in mind that theta should be a real number. So we move towards the second trigonometric function, that is cos theta. If you understand their concept, it will be easier for you to find the domain of any kind of trigonometric function. So cos theta, let's move towards the table where we have the values of cos theta here: 1 under root 3 by 2, 1 over under 2, 1 over 2, 0, minus 1, 0, 1. So it is again clear from here that cos theta is defined at all values of theta. So you need not to find any value of theta at which it is not defined. So here again we can say that the domain of, or you can say the valid value of theta is for all theta belongs to real number. It means theta is defined, cos theta is defined at all values of theta, and the theta should be a real number. There should not be any imaginary number. So then we move towards the tan theta. Now what will be the domain of tan theta? Now tan theta is basically dependent on sine and cos. So you cannot say that as sine and cos belongs to as sine and cos are defined at all values of theta, then it is possible that tan theta will also be. No. Let's look at the table. Tan theta, we have tan 0 at 0, 1 over under root 3, 1 under root 3, but we have the value tan 90 that is not defined. It means tan theta is not defined at theta is equals to 90 degree. It means we can never take the value of theta as 90 degree for the domain, as it will become undefined. Okay, then we move towards 180 degree, it is 0. Then again you came across 270 degree, it is again not defined. So from here we deduce that in tan theta, the theta is not defined at the odd multiples of theta. Like here it was pi by 2, here 3 pi by 2, and again at 5 pi by 2 it is not defined, then 7 pi by 2, then 9 pi by 2. So it means tan theta is not defined at odd multiples of pi by 2. Let's find its domain in another way, as we know that tan theta is equals to sine theta over cos theta. Now for finding the domain of a function where there is a denominator, there is a condition that you have to keep in mind, that denominator should not be equals to 0. It means if you came across the 0 in the denominator, it will make the function undefined. It means then tan theta will become undefined, and we cannot say that the function is defined at the given value of theta. So we have to put this condition whatever the function you have. So here in the denominator we have cos theta should not be equals to 0. if I further simplify it as theta should not be equals to cos inverse of 0. Now cos inverse of 0 is equals to what? 90 degree, as cos inverse of 0 is 90 degree. Cos inverse of 0 is, it means that the cos is 0 at which angle? Cos is 0 at 90 degree angle. So from here we can say that theta should not be equals to pi by 2. It means in the denominator you should not come across the angle that is theta equals to pi by 2. So from here we can also say that that tan theta is restricted with the value of theta at pi by 2. So other than pi by 2 we have seen in the table that it is also not defined at 3 pi by 2, then 5 pi by 2, then 7 pi by 2. So we have to find the generic domain here, that the domain of the tan theta will be, if I write here, domain will be for all theta belongs to real number but theta is not equals to 2n plus 1 pi by 2. Now what does it mean? This 2n plus 1 refers to the odd multiple. This is the generic formula that you have to memorize. So it refers to the odd multiple where n will be the integers. It can be -3, -2, -1, 0, 1, 1, 2, 3, any number. Then if you put any number of integer here, you will get the odd multiple of pi by 2. So it means theta is not defined at the odd multiple of pi by 2 in case of tan theta. So this is the domain of the tan theta. Then we move towards the cosecant theta. What will be the domain of cosecant theta? As we know that cosecant theta is equals to 1 over sine theta. So from here we can easily find the domain by using the concept that we have used in case of tan theta, that the denominator should not be equals to 0. And if I write that sine theta, that this is the denominator of the cosecant theta, it should not be equals to 0, but it will be refers to theta should not be equals to sine inverse of 0. So where the sine is 0? Sine is 0 at 0 degree, or sine is also 0 at 180 degree. Sine is also 0 at 360 degree. So it means theta should not be equals to 0 degree or 180 degree or 360 degree up to so on. It means theta should not be equals to multiples of 180. Theta should not be equals to the multiple of 180. If we look at the table in case of the cosecant theta, we have that the value of cosecant at 0 degree not defined, it is not defined at 180 degree, and it is also not defined at 360 degree. It means cosecant is not defined at the multiples of 180 degree. So we can say that the domain of cosecant theta is the domain, it will be equals to for all theta belongs to real number but theta is not equals to n pi. It means multiple of pi. So n can be any integer. Keep in your mind. So this is the domain of the cosecant theta. Now we move towards the secant and cot. So as we know that secant is the inverse trigonometric function of cos theta 1 over cos theta. So we can find its domain as the denominator, that is the cos theta, should not be equals to 0. Then theta is should not be equals to cos inverse of 0. So theta should not be equals to cos inverse of 0 refers to where the cos is 0, 90 degree or 270 degree. It means theta should not be equals to 90 degree or 270 degree or 540 degree. So from here it is clear that theta should not be equals to the odd multiples of 90. The domain will be for all theta belongs to real number but theta should not be equals to 2n plus 1 pi by 2, as 2n plus 1 refers to the generic formula for the odd multiples of pi by 2 where n could be -3, -2, -1, 0, 1 up to so on, could be any integer. So this is the domain of the secant theta. Now we move towards the domain of cot theta. This is the last function among the 6 trigonometric functions. So as we know that cot theta is equals to, as it is the inverse of the tan theta, so we can say that 1 divided by tan theta. Or we can also go with the concept of cos theta over sin theta, or we can also say that 1 over tan theta. We can take the 1 over tan theta as well. So we'll apply here the form again, finding the domain as the denominator should not be equals to 0. So it means theta should not be equals to tan inverse of 0. Now let's see where the tan is 0. Tan is 0 at 0 degree, at 180 degree and 360 degree. So it means theta should not be equals to 0 degree, 180 degree, 360 degree, or up to so on. From here it is clear that cot theta is defined at all values of theta except the multiples of 180 degree or multiples of pi. So what will be the domain? So the domain of cot theta will be for all theta belongs to real numbers, but theta is not equals to n pi. N could be any integer and pi refers to the 180 degree, that is it means that theta should not be equals to the multiple of pi. So other than this value, cot theta is defined at all values of theta. So that's all from today's lecture about how you can find the domain of the 6 trigonometric functions, and if you can easily understand their concept, you can find the domain of any kind of trigonometric function. Thank you.
Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.